Now we're going to use Lewis dot structures to show how ionic bonds are formed. We have calcium, which is in group 2 and has 2 valence electrons, and it's going to form a bond with chlorine, which has 7 valence electrons because it is in group 17. Here we have one electron from calcium that is going to be transferred to chlorine. Now this chlorine is happy because it has achieved a full outer shell, but calcium is not because it still has one more to give away. So we're going to add another chlorine because this bond is only formed between calcium ions and chlorine ions. This electron would transfer to chlorine and the ionic bond formed is calcium that has a 2 positive, and then we're going to write each of our chlorines with all of the Lewis dot structures, or I should say all of the electrons to show the full Lewis dot structure for that ion, because the ions have gained electrons for nonmetals and the metal has given away its electrons. This is how we represent the ionic bond formed between calcium and chlorine. Let's do magnesium and oxygen. Magnesium is also in group 2, so it has 2 valence electrons, whereas oxygen is in group 16 and it will have 6 valence electrons. Magnesium will give this one electron to oxygen here and this second electron to oxygen there. This will form magnesium with a 2 positive charge and oxygen with a 2 negative charge. The next one is a bond formed between aluminum and sulfur. Aluminum is in group 13 and has 3 valence electrons. Sulfur is in group 16 and has 6 valence electrons. This first electron for aluminum can transfer here, and the second electron for this aluminum can transfer here. Now, sulfur is happy because it has a full 8, but aluminum still has one it wants to get rid of. So the only thing we can do is add another sulfur because remember, this bond is formed only between sulfur and aluminum. So this last aluminum electron, valence electron, can be transferred to the sulfur there. Aluminum is happy, but sulfur is not. So we will add another aluminum. You may now see that you would just continue to add another of one of the 2 atoms that we're using to form the bonds until each atom in the bond is satisfied. This aluminum electron can be transferred here. Now that this sulfur is happy, this aluminum is not, so we're going to add another sulfur. In this case, this electron can transfer here and this electron here. So now we have both aluminums with all electrons transferred to a sulfur and sulfur with each of its empty spaces with an electron from aluminum. To write this one, sulfur will have all of its electrons, aluminum without its electrons. And notice that I am alternating because I want to represent that electrostatic force that is holding these two or all of these atoms together. And that electrostatic force is the attraction between the positive and negative charges. So we have 3 sulfurs and 2 aluminums. And now looking at this, it makes it easier to see how you will write the chemical formulas. You will represent the 1 calcium and 2 chlorines in this first one by writing a subscript of 2. For the second one, we have a 1-to-1 ratio, which will be magnesium and oxygen. No subscript is letting us know that it is 1 for each. And for the second one, aluminum, there are 2, and sulfurs, there are 3. In each case, the metal is written first, with the nonmetal written second, and each chemical formula represents a bond that equals zero. That means that the total positives equal the total negatives.